Before we begin, please note that the information in this video is for educational and informational purposes only. This presentation is not intended to be a substitute for professional business, financial, or IT consulting. You should consult with a qualified professional before making any decisions based on the content of this video. Imagine this for a second. Your company just spent a fortune hiring a team of brilliant data scientists. These are PhDs, experts in machine learning, people who can literally see the future hidden inside your data. You're excited. Your CEO is excited. This is the team that's going to build the AI that revolutionizes your industry. But a year later, what are they actually doing? They're spending 80% of their time not building groundbreaking AI models, but wrestling with infrastructure. They're stuck in a digital mud pit, fighting with incompatible software libraries, debugging obscure driver issues, and spending weeks just trying to get a stable environment set up to run a single experiment. It's like you hired a team of world-class chefs, but instead of cooking, they're spending all their time trying to fix the plumbing and rewire the electricity in the kitchen. It's an insane waste of talent, time, and money. And it's the silent killer of AI initiatives at companies all across America. This is the great unspoken chasm in the world of business today. It's the gap between wanting to use AI and actually deploying it successfully at scale to make a real impact on your bottom line. Every executive wants to leverage AI. Every IT department is being asked to support it. But the reality is a nightmare of complexity. You have to match the right hardware with the right software. You need to manage a dizzying array of open source tools, each with its own update cycle and security vulnerabilities. You need to ensure governance, security, and compliance. And when something inevitably breaks at 3 in the morning, who do you call? The open source community on a forum? This complexity is why so many AI projects that could generate hundreds of millions of dollars in value, end up stuck in what we call pilot purgatory. They work on a data scientist's laptop, but they never make it into production where they can actually help the business. Now, what if that entire problem could just go away? What if there was a single unified platform, a kind of operating system for enterprise AI, that handled all of that complexity for you? A platform that was engineered from the silicon all the way up to the application layer to be stable, secure, and optimized? A platform that gives your brilliant, expensive data scientists a simple turnkey environment so they can stop being IT plumbers and start being the innovators you hired them to be? That platform exists, and it's called NVIDIA AI Enterprise. Over the next 10 parts of this series, we are going to pull back the curtain on what is arguably the most important technology platform for business in the 21st century. This isn't a technical deep dive for hardcore developers, though they'll get a lot out of it. This is a beginner's introduction, a strategic overview for the business leaders, the IT managers, and the decision makers who know they need to win with AI, but need a clear, straightforward guide on how to actually do it. We are going to demystify NVIDIA AI Enterprise. We'll break down exactly what it is, who it's for, and most importantly, what it can do for your organization. We're going to show you how it transforms AI from a chaotic, high-risk science experiment into a streamlined, predictable, and scalable business function, just like your CRM or your ERP system. By the end of this series, you will understand how to slash your AI development times from months to weeks, or even days. You will see how to provide your teams with the tools they need to build everything from advanced analytics and conversational AI to groundbreaking computer vision and drug discovery applications. And you will have a clear roadmap for building a powerful, future-proof AI infrastructure that becomes the engine of innovation for your entire company. So, what is NVIDIA AI Enterprise? At its core, it's best to think of it as a complete, end-to-end software and support layer that sits on top of NVIDIA's world-class hardware. We all know NVIDIA for their GPUs, the chips that power the AI revolution. But the hardware is only one piece of the puzzle. The real magic, the real business accelerator, is the software stack that unlocks the full potential of that hardware. For years, developers had to assemble this stack themselves. It was like building a car from 1,000 different parts from 1,000 different manufacturers. You'd get a chassis from one place, an engine from another, a transmission from a third, and then spend all your time trying to make them work together. It was a brutal, inefficient process. NVIDIA AI Enterprise changes the game. It's the fully assembled, factory-built, high-performance car. It's the entire integrated system. It includes the essential processing libraries. It includes the frameworks that data scientists love, like TensorFlow and PyTorch, but they're optimized, containerized, and guaranteed to work. It includes pre-trained models and development kits that give your team a massive head start. And crucially, it includes enterprise-grade support from NVIDIA itself. When something goes wrong, you have a single number to call. You have a team of experts on the hook to solve your problem fast. This isn't just a collection of software. It's a curated, secure, and fully managed platform. Think of it like this: you wouldn't build your own cloud infrastructure from scratch, right? You use AWS or Azure or Google Cloud because they've handled the underlying complexity of networking, storage, and compute for you. NVIDIA AI Enterprise does the exact same thing, but for the world of high-performance AI. It is the operating system that abstracts away the complexity so your teams can focus on what they do best: building applications that create business value. This platform is designed to run anywhere your business needs it to run. You can deploy it in your own data center on-premise. You can run it in a private cloud, or you can run it on every major public cloud provider. This hybrid cloud, multi-cloud flexibility is absolutely critical. It means you aren't locked into one vendor. You can train a model in the cloud where you have massive scale, and then deploy it on an edge device in your factory or in your own secure data center for inference. It gives you the freedom to build and run your AI where it makes the most sense for your data, your budget, and your security requirements. This is the fundamental shift in thinking. AI is no longer a niche workload run by a few specialists in a lab. It's becoming a core pillar of modern business, and it needs a platform that is as robust, secure, and manageable as any other piece of mission-critical enterprise infrastructure. That is the problem that NVIDIA AI Enterprise was built to solve. It's about taking AI out of the lab and safely, securely, and efficiently deploying it across your entire organization. So, how does it actually accomplish this? It's built on a foundation of powerful components and frameworks, each designed to tackle a specific part of the AI lifecycle, from data preparation and model training to simulation and final deployment. It's a vast and powerful ecosystem, and in the rest of this series we're going to explore it piece by piece. We'll look at the tools that accelerate data processing, the software that orchestrates massive training jobs, and the frameworks that allow you to build and deploy everything from a customer service chatbot to a digital twin of your entire supply chain. The journey from AI ambition to AI reality is filled with challenges. But for the first time, there is a clear paved road through the wilderness. The question is no longer if you can leverage AI, but how fast you can deploy it to start winning. And the answer to how fast lies in understanding this foundational platform. So let's break down what that foundational platform actually is, because it's a term that gets thrown around a lot. Imagine you want to build a superhighway from New York to Los Angeles, but instead of a unified plan, you give a small piece of the project to 1,000 different contractors. One guy in Ohio is responsible for 5 feet of asphalt. A team in Nevada is in charge of a single guardrail. A crew in Kansas is mixing concrete, but their formula is slightly different from the crew in Colorado. Nobody is talking to each other. What do you get? You get a disaster. You get a road that's uneven, unsafe, and ultimately unusable. For years, this is what building enterprise AI felt like. It was a DIY nightmare. You'd have your data scientists, brilliant people, who would go out and find the best open source tools for a specific task. They'd grab a data processing library from here, a machine learning framework from there, a model deployment tool from somewhere else. They'd bolt them all together, creating this Frankenstein's monster of a software stack. And for a little while in the lab it would work. The monster would twitch, it would take a few steps. Everyone would high-five. But then you try to take that monster out of the lab and put it into the real world, what we call production. And it all falls apart. The data processing library gets an update, and it suddenly breaks the machine learning framework. The security team takes one look at the dozen open source components and has a collective heart attack because they can't possibly vet all of them for vulnerabilities. The hardware, the expensive GPUs you bought, aren't being used efficiently because the software drivers aren't optimized for this specific combination of tools. Your brilliant data scientists are no longer doing data science. They're now full-time mechanics, spending 80% of their time just trying to keep this rickety machine running. It's slow. It's expensive. It's incredibly risky. This is the wilderness we talked about. It's the reason countless AI projects that could have changed companies, have died a slow, painful death before ever seeing the light of day. NVIDIA AI Enterprise is the answer to that chaos. It is the unified plan for the superhighway. It's an end-to-end, cloud-native, fully supported software platform. Now that's a mouthful of marketing buzzwords, so let's translate that into English. End-to-end means it covers the entire AI journey. From the moment you start preparing your data, to training your massive models, all the way to deploying those models so your customers can actually use them. It's not just one piece of the puzzle, it's the whole box. Cloud native means it was designed to run anywhere and everywhere modern applications live. On your own servers in your data center, what we call on-prem. In a public cloud like Amazon Web Services, Google Cloud, or Microsoft Azure. Or in a hybrid model that uses a mix of both. It's flexible and built for the way businesses operate today. And the most important part, fully supported. This is the absolute game changer. Remember our Frankenstein's monster made of open source parts? If one of those parts breaks, who do you call? The answer is nobody. You post on a forum and pray some stranger has seen the same problem. With NVIDIA AI Enterprise, you have one phone number to call. You get enterprise-grade support, security patches, and performance guarantees directly from the people who built the hardware and the software. It's like having the original architects of the superhighway on speed dial 24/7. So, what's actually inside this platform? Think of it as a perfectly organized 3-layer cake. The bottom layer, the foundation, is all about making the hardware and software talk to each other perfectly. This includes things like NVIDIA's drivers and something called the Kubernetes operator. You don't need to be an expert on this, but just know this layer is the invisible magic that ensures your expensive GPUs are being used to their absolute maximum potential. It's the perfectly graded roadbed and reinforced concrete of our superhighway. It's boring, but without it, everything built on top would crumble. The middle layer is where it gets exciting. This is the collection of AI and data science tools themselves. These are the engines of innovation. You get access to over 50 different frameworks and pre-trained models. This includes the titans of the industry you've heard of like TensorFlow and PyTorch, but they're optimized by NVIDIA to run faster and more efficiently. It includes specialized tools like the Rapid Suite for accelerating data science, which can take a process that used to take 10 hours and shrink it down to 10 minutes. It includes the NVIDIA Triton Inference Server, a powerful engine for deploying your trained models at massive scale. This layer is like having a perfectly curated garage full of every vehicle you could ever need. You need a Formula One car for a speed-critical task? It's right there, gassed up and ready. You need a massive semi-truck for a heavy data hauling job? The keys are waiting. And the best part? They are all guaranteed to work perfectly on the highway you've built. No compatibility issues. No surprise breakdowns. And then there's the top layer. This is the application layer, with pre-built solutions that are almost like AI in a box. For example, NVIDIA Riva provides a complete toolkit for building world-class conversational AI. Think custom voice assistants or real-time translation services. NVIDIA Metropolis gives you the tools to build computer vision applications, like smart cameras that can detect manufacturing defects or manage city traffic. These are powerful pre-packaged solutions that can save you thousands of hours of development time. So you have the foundation, the tools, and the applications, all 3 layers working together in perfect harmony. It's not a random collection of parts. It's a single cohesive instrument. It's the difference between a high school garage band where everyone is slightly out of tune and the New York Philharmonic. Both are making noise, but only one is creating a masterpiece. What this fundamentally means for a business or for a developer is a radical shift in focus. You stop wasting time on plumbing and infrastructure. You stop worrying about compatibility, security, and stability. That is all handled for you. The platform becomes a utility like electricity. You don't think about how the power gets to your building. You just plug in your tools and start creating. This unlocks incredible speed. The time it takes to go from a promising idea to a working prototype is compressed from months or even years down to weeks. It democratizes access to this technology. You no longer need a small army of PhDs in systems engineering just to get an AI project off the ground. A small, focused team can now achieve what was previously only possible for tech giants with bottomless budgets. And it provides peace of mind. For a chief technology officer or a head of IT, this is everything. Knowing you have a secure, stable, and fully supported platform means you can confidently build mission-critical applications on it. You can build the AI-powered features that will define the future of your company, without lying awake at night wondering if a random open-source update is going to bring the whole system crashing down. This is the core promise of NVIDIA AI Enterprise. It's not just software. It's a paved road through the wilderness. It's a standardized, professional-grade system that removes the friction and the risk, allowing you to move at the speed of your ideas. So we have this incredible superhighway, this perfectly tuned orchestra. But who gets to use it? Is this just for massive Fortune 500 companies with dedicated data centers? Is it only for the elite cloud-based startups with millions in venture capital funding? Or can a smaller business, a university research lab, Or even a single ambitious developer tap into this power? The answer to that question reveals the true strategic genius behind this platform, and it's changing who gets to compete and win in the age of AI. It all comes down to a single fundamental problem. A problem that every single person trying to build serious AI has slammed into like a brick wall. And that problem is complexity. Building an AI application isn't like writing a simple piece of software. It's more like trying to assemble and race a Formula One car by yourself. Imagine this. You're the driver. You're a brilliant driver, one of the best in the world. Your goal is to get on the track and win the race. But in this scenario, there's no team. There's no pit crew. There's just you. So before you can even think about driving, you have to build the car from scratch. You have to source the engine, fabricate the chassis, design the aerodynamics, and mount the tires. Then you have to become the mechanic. You need to tune the engine, check the fluid levels, and make sure every single one of the thousands of components is working perfectly. You also have to be the data engineer, analyzing weather patterns and track conditions. And you have to be the strategist, planning your pit stops. By the time you finally get the car to the starting line, you're exhausted. You've spent 99% of your energy on tasks that have nothing to do with your actual talent. Driving. And while you were busy trying to figure out the right torque for a lug nut, a dozen other teams fully staffed with expert mechanics, engineers, and strategists have already completed the race and are celebrating on the podium. This right here is the reality for countless data scientists and developers today. The driver is the AI developer. The car is their revolutionary AI model. The engine is the raw, untamed power of NVIDIA's GPUs. But they are spending almost all their time being the mechanic, the engineer, and the strategist. They're wrestling with hardware drivers, debugging incompatible software libraries, managing complex data pipelines, and trying to get hundreds of different open-source tools to talk to each other without crashing. They are not driving. They are stuck in the garage. NVIDIA saw this. They saw the most brilliant minds in the world, armed with the most powerful processors ever created, spending their days on low-level, frustrating, and time-consuming plumbing. And they decided to solve it. They decided to build the entire professional pit crew, the state-of-the-art garage, and the entire support team and package it all up. That package is NVIDIA AI Enterprise. It is the great enabler. It's the system that says to the driver, forget about the lug nuts. Forget about the engine diagnostics. Forget about the fuel mix. You just focus on one thing, driving faster than everyone else. We'll handle the rest. So what does this pit crew actually do? Let's break it down. First, think about the tools and parts in the garage. In a normal garage, you might have a chaotic mess of tools from different brands, parts that don't quite fit, and outdated instruction manuals. It's a nightmare. NVIDIA AI Enterprise provides a pristine, organized, and certified set of tools and parts. This is the NVIDIA AI software platform, including things like Triton Inference Server, TensorRT, and Rapids. These aren't just random open-source tools pulled from the internet. These are tools built by NVIDIA for NVIDIA hardware. They are optimized, tested, and guaranteed to work together seamlessly. It's like having a toolbox where every single wrench is perfectly sized for every single bolt on your car. The guesswork is gone. The frustration is gone. Next, you have the actual mechanics, the ones who do the heavy lifting. In the world of AI, this is about managing the software environment. A huge challenge is that one AI model might need a specific version of a tool, say Python 3.8, while another model needs Python 3.9. In the past, this would cause massive conflicts. It's like trying to put Ford parts on a Ferrari. NVIDIA AI Enterprise uses a technology called containerization. Think of it like this. Instead of trying to change the parts on the car itself, you have pre-packaged tire assemblies ready to go. One assembly has rain tires, another has slicks. You can swap the entire unit in seconds without affecting the rest of the car. These containers package up an AI model and all its specific dependencies so it runs perfectly every single time on any system. No more conflicts. No more "it worked on my machine" headaches. But who tells all these mechanics what to do and when? You need a crew chief. In our analogy, this is the orchestration layer, powered by a technology you may have heard of called Kubernetes. Kubernetes is the master coordinator. It's the guy with the headset and the clipboard who sees the entire race. It knows which cars need to come into the pit, what resources they need, and it directs the flow of the entire operation. If one part of your AI application needs more GPU power, Kubernetes automatically assigns it. If a component fails, Kubernetes instantly reroutes the work to a healthy one. It's the intelligence that manages the entire fleet, ensuring maximum performance and reliability without the driver ever having to think about it. And then there's the most critical part of any professional racing team: the support and security. A Formula One team doesn't just show up on race day. They have a multi-year contract with their engine supplier. They get priority support, expert guidance, and guarantees that their components are secure and reliable. This is the enterprise part of NVIDIA AI Enterprise. It's a promise. It's a commitment from NVIDIA that they will stand behind this entire platform. You get long-term support, security patches, and access to NVIDIA's own experts to help you solve problems. For a business, this is non-negotiable. You can't build a mission-critical billion-dollar AI service on a patchwork of open-source tools with no one to call when something goes wrong. You need a throat to choke. NVIDIA AI Enterprise gives you that enterprise-grade reliability and peace of mind. So let's put it all together. Without NVIDIA AI Enterprise, you're the lone driver, stuck in the garage trying to build a race car from a pile of mismatched parts. You might eventually get it running, but the race will be long over. With NVIDIA AI Enterprise, you are handed the keys to a championship-winning car, supported by a world-class pit crew that handles everything. The optimized tools are laid out. The containerized components are ready to be swapped in an instant. The crew chief is orchestrating the entire workflow, and the full backing of the manufacturer is behind you. This fundamentally changes the game. It means a small team at a regional bank can develop fraud detection models that are just as sophisticated as those at a Wall Street megafirm. It means a university research lab can process genomic data at a scale that was previously only possible at a national supercomputing center. It means a startup with 3 people in a garage can build and deploy a generative AI application that competes with the tech giants. It democratizes access to high-performance AI by abstracting away the soul-crushing complexity of the underlying infrastructure. It shifts the focus from "can we build it?" to "what should we build?" It lets the experts be experts. It lets the drivers drive. But this platform isn't just about making things easier. It's also about making them faster. Not just faster to develop, but faster in terms of raw computational performance. Because hidden within this ecosystem of tools and support is NVIDIA's secret sauce: a collection of software development kits, or SDKs, and pre-trained models that are like having access to the race team's simulation data and secret engine designs. These are the cheat codes that can take your AI project from 0 to 60 in record time, giving you an almost unfair advantage. And understanding what these are and how to use them is the key to unlocking the true potential of this platform. So let's pull back the curtain on these cheat codes. The first, and arguably the most powerful, are called NVIDIA AI workflows. Now, that sounds a bit corporate, a bit jargony. So let's ditch the jargon. Think of an AI workflow as a Michelin star meal kit for a specific, complex business problem. Imagine you want to cook a world-class beef Wellington. You could spend years going to culinary school, mastering puff pastry, learning the perfect sear, sourcing the finest ingredients. Or you could get a meal kit designed by Gordon Ramsay himself. It comes with the pre-made pastry, the perfectly aged filet, the mushroom duxelle, and a step-by-step, no-fail recipe card. You're not just getting ingredients. You're getting the entire process, the expertise, the proven path to success. That is an AI workflow. It's not just a model. It's not just a piece of software. It's an entire end-to-end recipe for solving a real-world problem. It includes the pre-trained models, the necessary software development kits or SDKs, the code, the connectors to popular data sources, and even Helm charts and Jupyter notebooks to make deployment and customization a breeze. It is a complete, packaged solution, rigorously tested and optimized by NVIDIA's own experts to run on their hardware. Let's make this real. A huge challenge for big companies is understanding the thousands of customer service calls they get every single day. Buried in those calls are golden nuggets of information. Are customers happy? Are they complaining about a new product feature? Is there a widespread outage they don't know about yet? Having people listen to all those calls is impossible. So, NVIDIA offers a contact center intelligence workflow. This isn't a single tool. It's the whole kitchen. It uses NVIDIA Riva, their speech AI SDK, to take the raw audio from a phone call and transcribe it into text with incredible accuracy, even with different accents or background noise. That's step 1, the prep work. Then it uses a pre-trained large language model, fine-tuned for sentiment analysis, to read that text and understand the emotion behind the words. Is the customer frustrated? Delighted? Confused? It can classify the call's intent. Is it a billing question? a technical support issue, a sales inquiry. It can even perform entity recognition, pulling out key terms like product names or case numbers. Finally, it packages all of this into a visual dashboard. So a manager doesn't see a wall of text. They see a chart showing customer sentiment dipping after a new software update. They get an alert that calls about product X not turning on have spiked by 300% in the last hour. They have gone from a mountain of noise to a clear, actionable signal. And the company that uses this workflow? They didn't have to spend 2 years and millions of dollars hiring PhDs to build separate systems for transcription, sentiment analysis, and classification, and then figure out how to stitch them all together. They downloaded the meal kit. They followed the recipe. And in a fraction of the time, they have a world-class AI solution running, delivering real business value. That's the power of a workflow. It's the difference between building a car from scratch, smelting the steel, designing the engine, and getting a high-performance crate engine from a professional racing team that you can drop right into your project car. NVIDIA has done the hard, foundational engineering so you can focus on building your specific application and winning the race. Workflows exist for dozens of use cases. Cybersecurity, using AI to detect network threats in real time. Drug discovery, accelerating the search for new medicines. Digital twins for manufacturing, creating virtual replicas of factories to optimize production lines. Each one is a full-stack, enterprise-grade starting point. Now, inside these fancy meal kits, we find the second type of cheat code, the pre-trained models. If AI workflows are the complete recipe, pre-trained models are the professionally made core ingredients. They are the perfectly reduced demi-glace, the 72-hour fermented sourdough starter. They are components that are incredibly difficult and expensive to make from scratch, but you can simply take them and incorporate them into your own creations. Let's be clear about what a pre-trained model is. Training a large AI model from zero is a monumental task. You need massive datasets. We're talking about scraping a huge portion of the internet. Then you need an army of GPUs, running for weeks or even months, consuming an incredible amount of electricity and costing millions of dollars. The foundational models that power things like ChatGPT are the result of this colossal effort. Most companies do not have the resources, the time, or the need to do this. What they have is a more specific problem. A hospital, for example, doesn't need a model that knows about poetry and celebrity gossip. It needs a model that can look at an MRI scan and identify potential anomalies. A retailer doesn't need a model that can write a sonnet. It needs a model that can look at a photo of a dress and recommend similar items. This is where pre-trained models come in. NVIDIA takes these giant foundational models that they've already spent the millions to train on general data and makes them available to you. So, they have a computer vision model that's already been trained on billions of images. It already knows what edges are, what shapes are, what textures are. It understands the fundamental concept of seeing. You don't have to teach it how to see. You just have to teach it what you want it to look for. This process is called transfer learning or fine-tuning, and it is a complete game changer. That hospital can take NVIDIA's pre-trained vision model and then show it a much smaller, specialized dataset of a few thousand anonymized MRI scans. The model already understands pixels and shapes. Now it just learns the specific patterns that correlate with a tumor or a fracture. Instead of taking months in a supercomputer, this fine-tuning process can take just hours on a single server. You're leveraging that massive multi-million-dollar initial training, that AI college education, and then just giving it a quick specialized job training course for your specific task. NVIDIA offers a catalog of these models through a service called NGC, which is like a GitHub for enterprise-grade AI. You can find models for all sorts of things. Models that can understand human speech. Models that can generate photorealistic images from a text prompt. Models that can analyze text and summarize it. Models optimized for biology, for physics, for finance. And they are not black boxes. They come with model cards that tell you exactly what data they were trained on, their performance benchmarks, and their potential biases. This is critical for enterprise use where you need to be able to trust and explain how your AI is making decisions. So let's put it all together. You're a business. You have a problem you think AI can solve. Instead of starting with a blank sheet of paper, you check NVIDIA AI Enterprise. Option A, you find a complete AI workflow that matches your problem, like the contact center one. You get the whole meal kit, the end-to-end solution. You deploy it, customize it a little, and you're off to the races. Option B, your problem is a bit more unique. There's no pre-built workflow for it. So, you go to the NGC catalog and find a pre-trained model that gives you a massive head start. You grab that vision model or that language model, that professionally made ingredient, and you fine-tune it on your own data. You've just saved 99% of the time and cost of building a model from scratch. This two-tiered system of workflows and models is the engine of acceleration. It's what lowers the barrier to entry for world-class AI. It democratizes a technology that was once only accessible to a handful of tech giants. It allows a mid-sized bank, a regional hospital, or a startup to deploy AI solutions with the same power and sophistication as a Google or a Meta. This is the core value proposition: speed, reliability, and a lower risk of failure. You're not gambling on a research project. You're starting with proven, tested, and optimized components. We've now seen the what, the incredible prepackaged software, the workflows, the models that sit at the top of the stack. It's the application layer, the part that directly solves business problems. But having a world-class recipe and the finest ingredients is useless if you don't have a professional kitchen to cook in. How do you manage all this? How do you actually run these powerful models in a stable, secure, and scalable way? How do you get them out of the developer's laptop and into a production environment that can handle thousands of users? That requires an entirely different set of tools, an operating system for AI. And that brings us to the next critical layer of the NVIDIA AI Enterprise platform. This operating system for AI is where the rubber truly meets the road. It's the bridge between raw, powerful hardware and the intelligent applications you actually want to run. Think about your own computer for a second. You don't buy a collection of silicon chips, a motherboard, and a power supply to then manually tell the processor how to draw a window on the screen. That would be insane. Instead, you have an operating system like Windows or Mac OS. It's the master coordinator, the conductor of the orchestra. It manages all the complex hardware, providing a simple, stable platform so that you can just click on an icon and run an application like a web browser or a video game. NVIDIA AI Enterprise provides this exact same function, but for the world of artificial intelligence. It's a layer of software that sits on top of all that powerful server hardware and turns a chaotic collection of GPUs, CPUs, and networking cards into a single, cohesive, manageable AI factory. Without this layer, you have anarchy. Imagine a company with a dozen data scientists and a server rack full of powerful GPUs. Sarah is trying to run a critical application that analyzes customer feedback in real time. It needs a small, consistent slice of GPU power to function. At the same time, David decides to kick off a massive, week-long training job for a new large language model. He just grabs every GPU he can find, consuming 90% of the entire system's resources. Suddenly, Sarah's real-time app crashes. The customer feedback analysis goes dark. The business is flying blind. Meanwhile, another developer, Maria, just needs to run a quick test. But she can't get a single GPU because David's job has a death grip on everything. This is the digital equivalent of the Wild West. It's inefficient, it's unreliable, and it slows innovation to a crawl. You have a supercomputer that's being used like a shared, clunky desktop from the 1990s. This is the exact problem this AI operating system layer is built to solve. And it's built on two of the most revolutionary technologies in modern computing: containers and Kubernetes. Let's start with containers. You've probably heard the phrase from a developer, "Well, it worked on my machine." This is one of the most frustrating problems in software. A data scientist like David builds a brilliant AI model on his laptop. It works perfectly. He hands the code over to the IT team to put it into production, and it completely fails. Why? Because the production server has a different version of a specific library, a different driver, or a slightly different configuration. It's a nightmare of tiny, invisible differences that break everything. Containers solve this. Imagine you're shipping a fragile, complex piece of equipment across the country. You wouldn't just throw it in the back of a truck. You would build a custom crate. You'd pack the equipment inside with all its necessary cables, its power supply, and its instruction manual, all perfectly padded and secured. That crate can then be loaded onto any truck, any train, or any ship, and you know that when it arrives, everything inside will be exactly as you packed it. A software container, often managed by a tool called Docker, is that shipping crate for your application. The data scientist packages the AI model, all its code, all its specific libraries, and all its dependencies into a single, neat, self-contained box. This container can then be run on a developer's laptop, a testing server, or a massive production cloud, and it will behave identically everywhere. The "it worked on my machine" problem vanishes. So now we have these perfect, portable boxes for our AI applications. But that just creates a new problem. If you have hundreds or even thousands of these container boxes, how do you manage them? Who decides which server each box runs on? What happens if a server fails? How do you make sure the most important boxes get the resources they need? That's where Kubernetes comes in. Kubernetes is the master logistics manager for your container port. It's the air traffic controller for all your applications. You don't tell Kubernetes, put this container on server number 3. Instead, you just hand your container to Kubernetes and say, here's my application. I need 5 copies of it running at all times, and each one needs access to a GPU. Kubernetes then takes over. It looks at all the available servers in your data center, finds the ones with available GPUs, and strategically places your containers on them. It constantly monitors their health. If a server goes offline, Kubernetes instantly notices and automatically starts a replacement container on a healthy server. If your application suddenly gets a huge spike in traffic, you can tell Kubernetes to scale up from 5 copies to 50, and it will handle everything. It's the automation engine that turns your collection of servers into a resilient, self-healing system. So, containers package the AI and Kubernetes orchestrates it. This is the foundation of the modern cloud. But there's a catch. Standard, off-the-shelf Kubernetes is not built for AI. It knows about CPUs, memory, and storage, but it is completely clueless about GPUs. To vanilla Kubernetes, a state-of-the-art NVIDIA H100 GPU is just some unknown PCI device. It doesn't know how to schedule work on it, how to monitor its temperature, or how to divide its power among multiple users. This is where NVIDIA's genius comes in. NVIDIA AI Enterprise injects the critical AI awareness directly into Kubernetes. It provides a suite of software like the NVIDIA GPU operator, which acts as a translator. It teaches Kubernetes to speak fluent GPU. Suddenly, Kubernetes doesn't just see a server. It sees a server with 8 H100 GPUs, each with a specific amount of memory and compute capability. It understands that one container needs a whole GPU, while another 10 containers might only need a small slice of one. This is made possible by technology that allows a single physical GPU to be partitioned into multiple, fully isolated virtual GPUs. Let's go back to our company. With NVIDIA AI Enterprise in place, the chaos is gone. David, the data scientist, packages his massive language model training job into a container. He submits it to the Kubernetes-based system, but he flags it as a lower priority batch processing job. Sarah packages her real-time customer feedback app and submits it with a high priority flag, requesting a small guaranteed slice of a GPU. Maria submits her quick test, also as a low priority job. The NVIDIA-aware Kubernetes system, the heart of the AI Enterprise platform, looks at all these requests. It sees Sarah's high-priority app and immediately carves out a secure, virtual GPU instance for it on one of the servers. It will run there untouched and stable, no matter what else happens. Then it looks at David's massive job and Maria's small test. It sees that there are GPUs available during the off hours, overnight. It intelligently schedules David's job to run then, using all the available power without disrupting anyone. It slots Maria's test into a free 5-minute window on another partitioned GPU. Everyone gets the resources they need when they need them. The hardware is utilized with maximum efficiency. The business-critical applications are protected, and the entire system is automated and managed from a central point. This isn't just a technical improvement. It's a fundamental business transformation. It's the difference between AI being a series of ad hoc, fragile science projects and AI being a predictable, scalable, and reliable production factory. It establishes the rules of the road, the traffic signals, and the automated highway patrol for your entire AI infrastructure. So now we have the foundation, we have the powerful, accelerated hardware, and we have the sophisticated AI operating system to manage it all. We have built the world's most advanced factory floor. But what are we going to build in it? What are the tools, the machines, and the prefabricated parts that will actually create the AI? Because building AI from scratch is still incredibly hard. We need optimized frameworks, pre-trained models, and data processing engines. We need a toolbox, not just an empty workshop. And that brings us to the next, and perhaps most powerful layer of the NVIDIA AI Enterprise stack, the library of accelerated AI software. This is where the rubber truly meets the road. Because having the world's best workshop is useless if you don't have the tools to actually build anything. And the NVIDIA AI Enterprise software library isn't just a handful of wrenches and screwdrivers. It's a state-of-the-art collection of specialized, high-performance power tools, each one engineered for a specific, demanding task in the AI development lifecycle. Think of it as the ultimate AI toolkit, curated and optimized by the very people who design the hardware it runs on. So let's open this toolbox and see what's inside. At the very bottom, supporting everything else, is the technology we've mentioned before, CUDA. If the GPUs are the engines, CUDA is the language we use to speak to them. It's the fundamental programming model that unlocks the massive parallel processing power of NVIDIA GPUs. Every single tool we're about to discuss is built on top of CUDA. It's the non-negotiable foundation that makes all the acceleration possible. Now let's get to the big applications. First up, let's talk about data. All AI begins with data, usually massive, messy, overwhelming amounts of it. For decades, data scientists have relied on CPU-based tools like Pandas and scikit-learn to wrangle this data. And they're great, but they have a speed limit. When you're dealing with terabytes of information, great isn't good enough. You need impossible. This is where NVIDIA Rapids comes in. Rapids is a suite of open-source software libraries for executing end-to-end data science and analytics pipelines entirely on GPUs. Let me translate that. It takes the familiar, beloved tools that data scientists already use and gives them superpowers. The APIs are often identical, meaning a data scientist can take code that used to run on a CPU, change a single line, literally one import statement, and suddenly it runs on a GPU often 10, 50, or even 100 times faster. Imagine you're a financial analyst trying to detect fraudulent transactions in a dataset of millions of credit card swipes. On a CPU, running the necessary calculations to find those tiny anomalies could take hours, maybe even all night. By the time you find the fraud, the damage is done. With Rapids, that same analysis could take minutes. You're not just getting the answer faster. You're changing the types of questions you can even ask. You can analyze more data, build more complex models, and find insights in near real time. Rapids transforms data preparation and model training from a bottleneck into a speedway. Okay, so we've used Rapids to process our data and train a fantastic AI model. Now what? A model sitting on a developer's laptop is just a science project. To create business value, it needs to be deployed into production, where it can serve predictions to potentially thousands or millions of users simultaneously. This is one of the hardest parts of the entire AI lifecycle, often called the last-mile problem. This is where the NVIDIA Triton inference server steps in. If your AI models are the star performers, Triton is the world's most efficient and intelligent stage manager. It's a high-performance serving software that takes your trained models and makes them available for real-world applications. But it does so much more than that. First, it's framework agnostic. It doesn't care if you built your model in TensorFlow, PyTorch, TensorRT, or any other major framework. Triton can serve it. This is huge for enterprises that have different teams using different tools. Second, it's a master of optimization. It can run multiple models on the same GPU, or even spread a single large model across multiple GPUs, dynamically batching incoming requests to maximize throughput. It's constantly working to squeeze every last drop of performance out of your hardware, ensuring you get the lowest possible latency and the highest number of queries per second. Think of an e-commerce website on Black Friday. The recommendation engine, powered by an AI model, is getting hammered with requests. Triton ensures that every user gets a personalized recommendation in milliseconds, without the system crashing. It's the industrial-strength, battle-hardened engine that turns a model into a reliable, scalable service. Next, let's talk about the hottest area in AI right now: generative AI and large language models, or LLMs. We've all seen the power of models like ChatGPT. But what if you wanted to build your own? What if you needed a conversational AI that was fine-tuned on your company's internal documents, your product manuals, your customer support logs, so it could answer questions with expert knowledge specific to your business? For this, the toolbox contains the NVIDIA NeMo framework. NeMo is an end-to-end platform for developing and customizing generative AI models. It's not just a tool, it's a complete recipe book and factory. It gives you everything you need to take a powerful foundation model and tailor it for your specific domain. It provides frameworks for data curation, training with billions of parameters, and fine-tuning techniques like retrieval-augmented generation, or RAG, which allows the model to pull information from your private knowledge base. With NeMo, a hospital could build a medical chatbot that understands complex clinical notes. A law firm could create an assistant that can summarize legal precedents. It bridges the gap between general-purpose LLMs and domain-specific experts, allowing businesses to build truly proprietary and defensible AI capabilities. Finally, what about AI in the physical world? We're talking about cameras in retail stores on factory floors across city streets. There are billions of sensors out there, generating an unimaginable tsunami of video data every single second. How can we make sense of it all? The answer is NVIDIA Metropolis. Metropolis is a collection of tools and software development kits specifically for building vision AI applications. Think of it as a set of pre-built Lego blocks for understanding video. It has pre-trained models for detecting people, cars, and objects. It has libraries for tracking those objects as they move. It has tools for managing fleets of cameras and analyzing video streams in real time, either in the cloud or directly on edge devices. A retailer could use Metropolis to create an application that alerts staff when a shelf is empty, or analyzes foot traffic to optimize store layout. A city could use it to manage traffic flow and improve public safety. A logistics company could use it to automatically track packages moving through a warehouse. Metropolis provides the foundational technology to give sight and understanding to our physical environments. Rapid's Triton Nemo Metropolis, and this is just scratching the surface. But you might be thinking, wait a minute, a lot of these tools are based on open source projects. Can't I just download them myself for free? And that is the critical question. The answer reveals the core value of NVIDIA AI Enterprise. Yes, you can download the open source components, but what you're getting is a box of parts. You have to figure out which version of this library works with which version of that driver, which then needs a specific patch for your operating system, which then conflicts with another framework you need. This is what developers call dependency hell, and it can kill an AI project before it even starts. NVIDIA AI Enterprise is not a box of parts. It is a fully assembled, dyno-tested, high-performance engine. NVIDIA's engineers have done the painstaking work of curating, integrating, testing, and optimizing this entire software stack. They guarantee that every component works together seamlessly, from the silicon all the way up to the application. Furthermore, these aren't just the standard open-source versions. They are versions that have been enhanced and optimized by NVIDIA for maximum performance on their hardware. And most importantly, it all comes with enterprise-grade support. When your mission-critical, revenue-generating AI application has a problem, you don't post on a public forum and hope for the best. You pick up the phone and get direct access to NVIDIA's experts. That is the difference between a hobbyist project and an enterprise-grade solution. It's the assurance, the stability, and the performance guarantee that businesses absolutely require. So now our workshop is starting to look pretty incredible. We have the physical building on a solid foundation. We have power and plumbing installed and certified. The floor plan is laid out for maximum efficiency. And now we've filled it with a complete set of the most advanced, specialized power tools on the planet. We have everything we need to build literally any AI application imaginable. But even with the best tools, starting a complex project from a blank sheet of paper can be daunting. What if you didn't have to start from scratch? What if you had a set of blueprints, prefabricated components, and detailed assembly instructions to get you 90% of the way to your goal on day one? That's exactly the promise of NVIDIA AI Enterprise. It's not just a box of parts. It's a fully stocked, Michelin star-rated professional kitchen, and you've just been handed the keys. The ovens are preheated, the knives are sharpened, and many of the core ingredients are already prepared for you. This professional kitchen is NVIDIA's collection of AI software, and it's designed to slash your development time from years down to months, or even weeks. Let's start with the most powerful shortcut in modern AI: pre-trained models. Imagine you want to build an AI that can identify different types of vehicles in a live video feed: cars, trucks, motorcycles, buses. The old way, you'd need to gather millions of images of vehicles, hire a team to label them all, and then spend months and a fortune in computing power to teach a neural network from zero what a car even is. It's like teaching a child the entire concept of language before you can ask them to write a single sentence. A pre-trained model is the exact opposite. It's like hiring a seasoned expert who has already read every book in the library and seen every picture on the internet. They already know what a car is, what a wheel looks like, what a shadow is. They have a deep fundamental understanding of the visual world. You don't need to teach them from scratch. You just need to fine-tune their expertise for your specific task. Maybe you need them to identify not just cars, but 2023 Ford F-150s with a dent in the left fender. That's a much smaller, faster, and cheaper task. NVIDIA provides a massive library of these pre-trained models through its NGC catalog, which you can think of as an app store for AI brains. There are models for computer vision, for understanding human language, for analyzing medical images, for predicting customer behavior, and so much more. These models have been trained by NVIDIA on their own supercomputers for thousands of hours, representing an investment of millions of dollars in research and computation that you get to leverage instantly. Starting with a pre-trained model from NGC isn't just a head start. It's like starting the race 90 yards down a 100-yard dash. But having a brilliant expert is one thing. Giving them the right tools to do a specific job is another. That's where the next layer of the software stack comes in: SDKs and toolkits. An SDK, or software development kit, is a specialized set of tools built for a particular purpose. If a pre-trained model is the genius chef, the SDK is their custom-made set of knives, whisks, and pans, all perfectly designed for making a specific cuisine. NVIDIA AI Enterprise is packed with these toolkits, and let's explore a few to see how they change the game. First, there's the NVIDIA TAO Toolkit. TAO stands for Train, Adapt, and Optimize. This is the tool that lets you take one of those powerful pre-trained models from the NGC catalog and easily customize it with your own data. It's designed to be low-code, meaning you don't have to be a top-tier AI programmer to use it. The TAO Toolkit is a masterclass in efficiency. It guides you through the process of fine-tuning that general vehicle detection model to become an expert at identifying your company's specific fleet of delivery trucks, using only a few hundred of your own images instead of millions. It then helps you optimize that model so it runs incredibly fast and efficiently, ready to be deployed on a camera at a loading dock or in a delivery vehicle. Next, let's talk about language. Ever wonder how your smart speaker understands you? Or how customer service chatbots can hold a conversation that feels almost human? That magic is called conversational AI, and NVIDIA Riva is the SDK for building it. Riva gives you everything you need to build real-time speech AI applications. This includes world-class automatic speech recognition, turning spoken words into text and text to speech, which can generate incredibly lifelike, expressive human voices. With Riva, a hospital could build a voice-controlled system for surgeons in an operating room, or a drive-thru could deploy a system that takes orders perfectly every time regardless of background noise. Riva is the toolkit for giving your applications a voice and the ability to listen. Then there's the world of sight, at an enormous scale. Imagine a city where thousands of cameras are monitoring traffic flow to prevent gridlock in real time. Or a massive factory floor where every camera is a quality control inspector, spotting microscopic defects in products moving at high speed. This is the world NVIDIA Metropolis is built for. It's not just a single tool, but a comprehensive application framework for building vision AI at a massive scale. Metropolis provides the building blocks to process video streams from millions of sensors simultaneously, understand what's happening in them, and generate actionable insights. It's what transforms a simple security camera into a smart sensor that can improve safety, efficiency, and operations for everything from retail stores to entire cities. TAO Riva Metropolis. These are just a few examples. There are specialized SDKs for healthcare, for robotics, for high-performance computing, and more. Each one is a concentrated package of NVIDIA's expertise, designed to solve the hardest problems in a specific domain so you don't have to. So, we have the pre-trained expert models and we have the specialized toolkits. But what if you need more than just the ingredients and the high-end appliances? What if you need the entire detailed recipe, from start to finish, written and tested by a master chef? That's where NVIDIA AI workflows come in. An AI workflow is a complete, end-to-end reference example that shows you exactly how to build and deploy a specific type of AI solution. It's the blueprint. It includes the pre-trained models, the software tools, the code, the configuration files, everything, all packaged together in cloud-native containers using technology like Kubernetes. Let's say your goal is to build a sophisticated chatbot for your customer support center. Instead of figuring out all the pieces yourself, you can use the NVIDIA conversational AI workflow. It shows you exactly how to take a state-of-the-art large language model, fine-tune it with your company's support documents and chat logs using the TAO toolkit, and deploy it as a scalable service using Riva. It takes the guesswork out of the equation. It's a proven path from A to Z. These workflows cover a huge range of common enterprise use cases, detecting fraud in financial transactions, creating a recommendation engine for an e-commerce website, improving supply chain logistics, or analyzing customer sentiment from product reviews. Each workflow is a complete solution stack that's been engineered, tested, and optimized by NVIDIA to run on their certified hardware. It's the ultimate accelerator, providing a production-quality starting point that can save a development team thousands of hours of work. This is the core of the value proposition. NVIDIA AI Enterprise isn't just selling you access to software. It's providing a structured, accelerated path to building and deploying high-performance AI. It democratizes the technology. It allows a small team at a regional bank to build a fraud detection system that rivals one from a Wall Street giant. It empowers a startup to create a voice-based application with the same quality as a product from a trillion-dollar tech company. By providing the models, the specialized tools, and the step-by-step recipes, NVIDIA is abstracting away a massive amount of complexity. They've done the foundational work so you can focus on what makes your business unique, your data, your expertise, and your vision. So you have the models, the tools, and the recipes. You've used them to build your masterpiece. But now comes the most critical question of all. How do you serve it to millions of people, instantly and reliably? How do you take it from the test kitchen to a global restaurant chain, ensuring every customer gets the same perfect experience, every single time? This is the great filter. The chasm where 90% of artificial intelligence projects go to die. It's called the production gap, or the AI valley of death. It's the brutal, unforgiving journey from a perfect model in a lab to a rock-solid service in the real world. Because in the real world, "It works on my machine" is a meaningless phrase. In the real world, customers don't wait. Competitors don't sleep. And failure is not an option. The challenge is called inference. If training is the process of the AI model going to school and studying for the final exam, inference is the exam itself, happening a million times a second forever. It's the AI doing its job. It's the fraud detection system analyzing a transaction in milliseconds. It's the chatbot crafting a human-like response instantly. It's the diagnostic tool scanning a medical image and delivering its findings before the patient even leaves the room. And this is where the physics of the real world crash into the theory of the lab. Your perfect model, your culinary masterpiece, suddenly faces three brutal adversaries: latency, throughput, and utilization. Latency is the enemy of experience. It's the time it takes from asking a question to getting an answer. In our restaurant, it's the time from when a customer orders to when the food arrives. A few seconds of delay can be the difference between a happy user and a lost customer. For applications like self-driving cars or real-time bidding on ads, a delay of even a few milliseconds can be catastrophic. Throughput is the enemy of scale. It's how many requests you can handle at once. Your model might be fast for one user, but what happens when 10,000 users hit your service at the exact same moment on Black Friday? Can your kitchen serve 10,000 tables simultaneously? If not, the system grinds to a halt, orders are dropped, and your business suffers. And utilization is the enemy of your budget. Those GPUs that power your AI are incredibly powerful, but also incredibly expensive. If they're sitting idle waiting for the next request to come in, you are burning money. It's like having a world-class chef on $1 million salary who only cooks one meal an hour. You need to keep that hardware humming, squeezing every last drop of performance out of your investment. So how do you solve this? How do you build a system that is blindingly fast, can scale to infinity, and uses your expensive hardware to its absolute maximum potential? This is where NVIDIA introduces one of the most critical, yet often overlooked, pieces of the entire AI enterprise stack: the NVIDIA Triton Inference Server. If your AI model is the recipe, Triton is the entire five-star kitchen, the head chef, the logistics manager, and the quality control expert all rolled into one. It is a piece of open-source software, hardened and supported within AI Enterprise, designed specifically to solve the hellscape of AI deployment. First, Triton is a universal translator for AI models. In the real world, data science teams don't just use one tool. They build models in TensorFlow, PyTorch, TensorRT, ONNX, and a dozen other frameworks. Trying to deploy and manage all of these is a nightmare. It's like having a kitchen where every chef speaks a different language and uses completely different tools. Triton doesn't care. You give it a model from virtually any major framework, and it knows exactly how to serve it, optimized for performance on NVIDIA GPUs. It creates a single, standardized way to deploy everything. Second, Triton is a master of efficiency. It has incredibly sophisticated features working under the hood to maximize your throughput and utilization. One is called dynamic batching. Imagine customers arriving at your restaurant one by one. An inefficient kitchen would cook each order individually. A smart kitchen run by Triton would see multiple orders for the same dish coming in, group them together, batch them, and cook them all at once, saving immense time and energy. Triton does this automatically, bundling user requests together on the fly to feed the GPU in the most efficient way possible, dramatically increasing throughput. It also enables concurrent model execution. This means you can run multiple different AI models, even from different frameworks, on the same GPU at the same time. Your GPU is no longer dedicated to a single task. It can be running a language model for your chatbot, an image recognition model for content moderation, and a recommender engine, all simultaneously. It's like a master chef who can perfectly sear a steak, toss a pasta, and plate a dessert all at the same time on the same stove without breaking a sweat. This feature alone fundamentally changes the economics of AI infrastructure. But NVIDIA saw that even with a tool as powerful as Triton, there was still friction. Developers still had to find the right model, optimize it, package it, and configure it with Triton. It was a powerful kitchen, but you still had to source all the ingredients and prep them yourself. So they asked a revolutionary question: what if we did that for you? What if we gave you not just the kitchen, but a pre-packaged, ready-to-cook, Michelin star meal kit? The answer is NVIDIA NIMs, which stands for NVIDIA Inference Microservices. This is, without a doubt, one of the biggest leaps forward in making AI accessible for every enterprise. A NIM is a self-contained, hyper-optimized, production-ready AI model delivered as a simple, standardized container. Think about that. Inside one NIM, you get a state-of-the-art model like Meta's Llama 3 for chat, or a model for biology or cybersecurity that has already been painstakingly optimized by NVIDIA's own engineers to run with maximum performance. It's packaged with a pre-configured Triton inference server and a standard API. What does this mean in practice? It means the entire process of deploying a powerful generative AI model has been compressed from a months-long project for a team of specialists into a task that can take just a few minutes. You want to add a powerful chatbot to your company's customer service portal? In the past, that was a massive undertaking. You'd have to research models, acquire the weights, convert it to an optimized format, build a serving infrastructure, write the API code. It was a huge, expensive, and risky project. With NIMs, the process looks like this. You go to NVIDIA's catalog. You find the Llama 3 NIM. You run a single command to pull it down. You run another command to start it. And that's it. You now have a secure, stable, enterprise-grade inference server running one of the world's most powerful language models, live and ready to integrate into your application. It's not an exaggeration to say this changes everything. It's the App Store moment for enterprise AI. NIMs provide a standardized, secure, and supported path to production. Because they are part of the AI Enterprise platform, you know they are tested, patched for security vulnerabilities, and backed by NVIDIA's enterprise support. You're not just downloading some random model from the internet. You're deploying an industrial strength asset you can bet your business on. So we've come full circle. From the raw data and the powerful hardware, to the operating system, to the training frameworks, to the final trained model. And now, with Triton and NIMs, we have the engine to serve that intelligence to the world. We've built our global restaurant chain, with a standardized kitchen that can serve any dish, at lightning speed, to millions of customers. The AI is no longer trapped in the lab. It's out in the world creating value. But with this scale comes a new daunting challenge. You don't just have one AI application anymore. You have dozens, maybe hundreds, running across your organization. You have your restaurant chain. How do you manage it? How do you monitor the health of every single location, roll out new menu items, ensure quality control, and do it all without descending into absolute chaos? Well, in the restaurant world, you'd have a corporate headquarters, a central command, a single source of truth that oversees everything, not by micromanaging every single chef, but by providing the tools, the standards, and the visibility to run the entire operation smoothly. This is precisely the role of the management and orchestration layer within NVIDIA AI Enterprise. It's the brain, the central nervous system of your entire AI operation. Let's break that down. First, you have the problem of just managing the chaos. You might have hundreds of GPUs spread across servers in your data center, in the cloud, or even at the edge. How do you treat them not as individual isolated islands, but as one giant cohesive pool of computational power? This is where orchestration comes in. You've probably heard the term Kubernetes. Sounds complex, and frankly on its own it can be. But think of Kubernetes as the master scheduler for your entire restaurant chain. It's the operations manager who knows exactly which kitchen stations are free, which chefs are available, and what ingredients are in stock. When a developer, your brilliant new chef, comes along with a new AI model, a new recipe, they don't have to go and find an empty server, install all the right software and hope it works. They just hand the recipe to the operations manager, Kubernetes, and say, I need to cook this, and it requires this much oven space and this many prep stations. Kubernetes then looks across the entire chain of restaurants, all of your available GPUs, and finds the perfect spot to run that job automatically. It handles the scheduling, the resource allocation, and the placement. Now here's where NVIDIA AI Enterprise adds its secret sauce. Setting up and managing Kubernetes for GPU-intensive AI workloads is notoriously difficult. It's like trying to design a custom kitchen layout for every single new dish. It's slow, expensive, and prone to error. NVIDIA AI Enterprise provides something called the NVIDIA GPU Operator. This is a game changer. It automates the entire process. It's like having a master blueprint for the perfect high-performance AI kitchen. The operator automatically installs the right drivers, the right container runtimes, everything you need to make your GPUs first-class citizens in your Kubernetes environment. It turns a month-long setup nightmare into a few simple commands. You're not building kitchens anymore, you're just opening them. So now you have your kitchens running efficiently. But what are you cooking? This brings us to the next piece of the puzzle: the menu. A restaurant chain doesn't have every chef invent every single dish from scratch. That would be madness. They have a corporate-approved menu with standardized recipes that are tested, optimized, and known to be delicious. This is the NVIDIA NGC catalog. Think of the NGC catalog as the ultimate corporate recipe book for AI. It's a massive, curated library of pre-trained models, software development kits, and most importantly, performance-optimized containers. A container is like a perfect pre-packaged meal kit for your AI model. It has the model itself, all the right software libraries, all the dependencies, every single ingredient perfectly measured and packed into a standardized box. Your developer doesn't have to spend weeks hunting down the right version of PyTorch or TensorFlow and making sure it's compatible with the NVIDIA driver. They just pull the image classification meal kit or the large language model meal kit from the NGC catalog, and it works instantly. And these aren't just any recipes. They've been optimized by NVIDIA's own master chefs. They are tuned to extract every last drop of performance from your GPUs. We're talking about models that run faster, train in less time, and use resources more efficiently, all because they're built on this certified, optimized foundation. This completely changes the economics of AI development. Your team spends less time on tedious setup and plumbing, and more time innovating, creating new recipes, and adding value to the business. Okay, so your kitchens are automated, and your chefs are using standardized, high-quality recipes. The chain is growing. How do you, the CEO, keep an eye on everything? You need a dashboard. You need to see the health of every single location in real time. Are the ovens running too hot? Is one location getting way more customers than another? Is there a bottleneck in the supply chain? This is the world of monitoring and telemetry. NVIDIA AI Enterprise is built to plug directly into the tools that IT professionals already use, like Prometheus and Grafana. This allows you to create a single pane of glass, a master dashboard for your entire AI infrastructure. You can monitor GPU utilization, memory usage, temperature, and power consumption across every single server. You can see which teams are using which resources, track the performance of your models in production, and spot problems before they impact your customers. This isn't just about preventing failures. It's about optimization. By seeing how your resources are being used, you can make smarter decisions. Maybe you notice that your fraud detection models are busiest on Fridays. You can automatically scale up resources for them every Friday morning and scale them back down on Saturday, saving money and energy. This level of visibility turns your AI infrastructure from a black box into a transparent, finely tuned machine. It's the difference between guessing how your business is doing and knowing down to the last detail. Finally, let's talk about the most important person in the restaurant business: the health inspector. In the world of enterprise software, this is security, compliance, and support. When you're running open-source software you pulled from the internet, you are your own health inspector. If a critical security vulnerability is discovered, it's on you to find it, patch it, and pray it doesn't break anything else. It's a constant, terrifying tightrope walk. NVIDIA AI Enterprise completely flips this dynamic. Every single component, from the drivers to the Kubernetes operators to the containers in the NGC catalog, is scanned, tested, and hardened for security. NVIDIA proactively monitors for common vulnerabilities and exposures, or CVEs, and provides timely patches. But the real value is this: it's all supported. If something goes wrong, if a model isn't performing correctly, if a driver is causing issues, If you're having trouble scaling a workload, you have a direct line to NVIDIA's experts. You have an enterprise-grade service-level agreement. You can pick up the phone and talk to the people who built the hardware and the software. This is the corporate safety net. It's the peace of mind that allows you to deploy AI into mission-critical applications, the kind that handle financial transactions, patient data, or manufacturing quality control. You're not just buying software, you're buying confidence. You're buying the assurance that your AI factory is built on a foundation that is stable, secure, and backed by a world-class support organization. So let's put it all together. The management and orchestration layer of NVIDIA AI Enterprise isn't just one thing. It's the combination of the automated kitchen setup with the GPU operator, the Michelin star recipe book of the NGC catalog, the real-time CEO dashboard for monitoring everything, and the 5-star rating from the health inspector for security and support. It transforms a chaotic collection of powerful but disparate GPUs into a single, unified, and manageable AI production line. An AI factory that you can scale, secure, and rely on to power the future of your business. But what kind of products are these factories actually building? What are the world's most innovative companies creating with this incredible power? They're building the future, faster than we ever thought possible. They are solving problems that, just a decade ago, were considered science fiction. Let's start in the world of medicine, where the stakes are literally life and death. Companies at the forefront of drug discovery are using NVIDIA AI Enterprise to fundamentally change how we fight disease. The old way, a painstaking decade-long process of trial and error, costing billions of dollars to bring a single drug to market. The new way, an AI model, running on accelerated infrastructure, sifting through a database of millions of molecular compounds. It's not just searching, it's understanding. It simulates how each compound might interact with a specific protein linked to a disease, looking for that one perfect key to fit a complex biological lock. This process, which used to take years of lab work, can now be done in days or even hours. This is how we get personalized medicine. This is how we find cures for rare diseases. It's not just about speeding up the old process. It's about creating an entirely new one, powered by predictive intelligence. Now let's shift gears to the open road. How do you teach a car to drive? You can't just give it a driver's manual. It needs experience, millions of miles of it, in every conceivable condition. Driving every one of those miles in the real world would be impossibly slow, expensive, and dangerous. So, automotive giants are doing something extraordinary. Using tools within the NVIDIA ecosystem like NVIDIA Drive Sim, they build a perfect, physics-accurate digital twin of the world. A virtual San Francisco, a simulated Berlin, a digital Tokyo. Inside this virtual world, they can run millions of simulations simultaneously. They can test how their AI driver reacts to a sudden snowstorm in Denver, a child running into the street in a quiet suburb, or a complex, chaotic intersection during rush hour. They can run these edge case scenarios thousands of times per night, constantly refining the AI, making it safer and smarter. Every virtual mile makes every real-world mile safer for all of us. They are building trust in autonomous systems before the tires ever touch the pavement. But the impact isn't just in things we can see and touch. Consider the invisible world of finance, where trillions of dollars move at the speed of light. Every single second, millions of credit card swipes, bank transfers, and stock trades occur. Hidden within this massive data stream are sophisticated criminals attempting to commit fraud. A human team could never keep up. But an AI model trained and deployed using NVIDIA AI Enterprise can. Sees everything instantly. It analyzes every single transaction in real time, comparing it against a complex web of patterns and historical data to spot anomalies that signal fraud. It's not looking for one specific thing. It's understanding context. It knows that buying gas in Ohio and then 2 minutes later a plane ticket in Singapore is impossible. It flags the transaction, protects the customer, and saves the institution millions, all in the blink of an eye. It's like having the world's most vigilant detective watching over every single transaction, all at once. And this intelligence is reshaping our everyday experiences too. Think about retail. The world's biggest retailers are moving beyond simple recommendation engines. They're building true AI-powered experiences. They use computer vision models to monitor store shelves in real time, automatically alerting staff when a popular item is running low. They're using conversational AI, powered by frameworks like NVIDIA Riva, to create customer service chatbots that are actually helpful. Bots that understand nuance, that can access your order history, and that can solve complex problems without making you want to scream, "Let me talk to a human." They're using AI to manage incredibly complex supply chains, predicting demand with pinpoint accuracy to make sure the products you want are in stock, reducing waste and improving efficiency. They are turning the act of shopping into a seamless, personalized, and intelligent interaction. From designing life-saving drugs and building safer cars, to protecting our finances and revolutionizing how we shop, the common thread is a stable, secure, and scalable platform. NVIDIA AI Enterprise is that foundational layer. It's the operating system that connects ambitious ideas with the incredible computational power needed to make them a reality. It provides that full-stack, enterprise-supported environment we've been talking about, so these brilliant data scientists, engineers, and researchers can stop worrying about the plumbing, the complex work of managing drivers, containers, and dependencies, and focus entirely on their next breakthrough. It allows them to move from a prototype on a single workstation to a full-scale deployment across a massive cloud cluster, without changing their code or their workflow. And this is the most critical takeaway from our entire journey together. This level of power is no longer the exclusive domain of a few tech giants or government research labs. The very same end-to-end platform that is fueling these incredible innovations is becoming more accessible every single day. The barrier to entry for creating world-changing AI has never been lower. The power to build a custom application that can diagnose crop diseases from a drone image, to train a model that can predict weather patterns with greater accuracy, to deploy an intelligent service that helps people learn a new language, that power is now within reach of startups, universities, and even individual developers with a brilliant idea. We've spent this time together exploring the what, the why, and the how of this revolutionary platform. We've seen the software, the infrastructure, the support, and the astounding real-world results. But this isn't the end of the story. This is the beginning. This is the moment where the technology becomes so powerful and so accessible that it stops being the story, and it becomes the tool that allows us to write the next chapter of our own. The real question, the one that truly matters now, is what comes next. The tools are here. The platform is ready. The AI factory is open for business. The only thing left to ask is, what will you build?